Today we're going to be looking at the Pythagorean Theorem, how to deal with the Pythagorean Theorem. First, to use the Pythagorean Theorem, we need to have a right triangle. So when two of the three sides of a right triangle are known, and the third side can be found using our Pythagorean Theorem. We have here basic portions of our Pythagorean Theorem, of our triangle. We have here, these are what we call legs. And this is the hypotenuse. Okay. My legs, I refer to those as A and B. And it doesn't matter which one I call A or which one I call B. They are interchangeable. The hypotenuse is C. Now, hypotenuse has to always be C. It is the longest side of our triangle. The way the Pythagorean theorem works is if I square my legs, if I take my A and I square it, and then I take my B and square it, and then I add those two things together, it will always equal the hypotenuse squared, which is my C, my Pythagorean theorem. So looking at how the Pythagorean theorem actually works together in practice, I'm looking for my missing side of my triangle. If I draw just a quick triangle here, and my triangle here, this would be 7, this side would be 4, and this would be my C. The C is the missing side. So my formula says to do A squared plus B squared, and that will equal my C squared. A in this case will be 7, so I have 7 squared. B in this case is going to be 4, so that's going to be 4 squared. And C, well, it's going to be C. So for 7 squared, that's 49, because 7 times 7 is 49. 4 squared is going to be 16, because 4 times 4 is 16, and that gives me C squared. I go and add these things together, that gives me 65, and that's equal to my C squared. Now I'm looking for C, not C squared, so I have to take the square root of both sides. Square root of C squared and the square root of 65 will give me my C. 65. 65 cannot be simplified because that's only 5 times 13, so my final answer would be the square root of 65. Looking at another example here, this time my A is missing. So if I draw a quick little triangle here to look at and get a visual of what's going on, they gave me C, which is 16. This piece would be 12, and this piece is my A. Again, my formula says A squared plus B squared is equal to C squared. I go and substitute in the values that I'm given. A squared, I do not know. B, I do know B, that is 12, so that's 12 squared. I do know C, C is 16. A squared plus 12 squared is 144. 16 squared is 256. At this point, my goal is to get the A squared all by itself, so I'm going to subtract 144 from both sides of my equation. I now have A squared is equal to, well, that's going to be a 2, this is going to be a 1, that's a 1, 112. I now have to take the square root of both sides, the square root of A squared and the square root of 112. So it tells me that A is equal to the square root of 112. I have to make sure that these things are always simplified. 112 is the same thing as saying the square root of 16 times 7. Square root of 16 is 4, so A is going to be 4 times the square root of 7. Looking here at example number 3. Example number 3 again. First, I like to draw this up, a quick little triangle. Fill in the information given. I'm given that C is equal to 7. A in this case is going to be the square root of 17, and B is the missing portion this time. So my formula says A squared plus B squared is equal to C squared. A squared, that's going to be square root of 17 squared. B squared, I do not know B squared, so he's just chilling right there. C squared, well, C is 7, so that's going to be 7 to the second power. When I square a number with a radical, that just gives me the number inside the radical, which is going to be 17 plus b squared is equal to 49. My goal is to get the b squared by itself, so I have to subtract 17 from both sides. B squared is equal to 32. Now take the square root of both sides, so square root of b squared, square root of 32. B is equal to the square root of 32. Well, 32 can be rewritten as 16 times 2. Again, the square root of 16 is still 4, and my 2 is staying inside just chilling. Looking at example number 4. Here it says find the value of x. It's the same type of procedure that we were just doing. Instead of listing a, b, and c, they give me a triangle to work with. Again, I'm using the same formula. A squared plus b squared is equal to c squared. My a, my b, and then the x is going to represent my c. So I have 3 squared plus 7 squared is equal to x squared. 3 squared is 9, and 7 squared is 49, and that's my x squared. Add these together gives me 58 is equal to x squared. Take the square root of both sides, and I find that x is equal to the square root of 58. 58 is only 2 times 29, so it cannot be simplified. So that would be our final answer. Looking at example number 5. In example number 5, this time I have A. B is the one that's missing, and I have C. Using my same formula, A squared plus B squared is equal to C squared. A is going to be 6. This is going to be my x squared. And this over here is going to be 6 square root of 2 squared. This piece becomes 36 plus the x squared. Here, I'm going to have to multiply 6 square root of 2 times 6 square root of 2. Well, in doing so, 6 square root of 2 times 6 square root of 2, that gives me 36 square root of 4. Square root of 4 is going to be 2. So that's 36 times 2, which would be 72. So this is now 72 here. My goal is to get the x squared by itself, so I'm going to subtract 36 from both sides. Here I see that x squared is equal to 36. I take the square root of x squared, the square root of 36, and I find that x is equal to 6. Pythagorean Theorem. Pythagorean Theorem is one of the most useful formulas that you could ever come across. It's used daily in all types of professions. By learning this one little formula here, you can always make sure you have a perfect 90-degree angle for anything. And as always, as you're going through working through any problem, pay attention to what you're doing, and good luck.